Welcome to Edisoft Virtual Labs. The aim of the experiment is to determine the magnetic moment of an unknown magnet. The apparatus used will be a bar magnet and a deflection magnetometer on a meter scale. If the magnetometer needle, whose pole strength is M, is placed in two perpendicular fields of H and F, then its north pole is under the action of two forces, MH parallel to BH of the Earth's magnetic field, and MF parallel to F of an unknown bar magnet. Also, the south pole is under the action of forces in the contrary sense. These forces constitute couples, which keep the magnet in a position of equilibrium. From the figure one gets the following relation. Thus, if we know the strength of the field H and can observe the angle theta, we can determine the strength of the field F. In most experiments of this kind, the field F is only approximately uniform. For this reason, it is important that the needle of the magnetometer should not be too long. If the needle is short, only a small error is introduced by treating the field F as uniform. The magnetic moment M of a magnet of length 2L, and poles strength positive mu and negative mu, is given by the following equation. The force on unit north magnetic pole at P is as followed, where C is a constant. The resultant magnetic force at P is in the direction OP, and is given by the following equation. If R is large compared to L, the term in L squared may be neglected, and the force expression becomes as followed. Substitution of this force in equation 1 yields the following relation. This relation is a straight line between r cubed and cotan theta, with a slope of h by 2 mc, and from which m then mu are obtained, if c and h are known. Now let's start the experiment. Place the magnetometer box on a meter scale laid flat on the table, so that the center of the box coincides with the center of the scale. Let the zero line of the magnetometer pointing exactly along the length of the scale. Make sure the scale is pointing east and west, as judged by the magnetometer needle. Put the unknown magnet in one direction of the magnetometer arm, at a distance r from the needle center, and determine the angle of deviation of the needle θ1 and θ2. Repeat the last step with different distances from the needle center, and determine the angle of deviation of the needle θ1 and θ2 each time. Exchange the magnetic pole, and determine the angle of deviation of the needle in this new position θ3 and θ4, at different distances from the needle center. Repeat the previous steps with the same distances, but at the other arm of the magnetometer. Record your data in a table, and calculate the average deviation angle and its error. Plot the relation between r cubed and cotan θ average and find m from the slope.